Hello children, welcome back. So in today's class, let us discuss regarding the work done against gravity. Okay, here we go with work done against gravity. So whenever a body is lifted upwards, then the amount of force applied to lift the body is equals to the weight of the body. So the work done in lifting a body upwards is equal to the product of weight of the body and the height to which the body is lifted. To understand this clearly, let us consider the given condition. So let us consider that a body of mass m is lying on the ground. And now this body is to be lifted upwards, vertically upwards, to some height, say h. As I said that the mass of the body is m and this body is lifted vertically upwards to a height h, the amount of force required to lift the body upwards is equals to the weight of the body, is equals to the weight of the body. So that force in lifting the body F is equals to weight, means the product of mass and acceleration due to gravity. So F is equals to mg. So work done in lifting the body, general formula for work done is equals to force into displacement. And as we know that the force required to lift the body is nothing but the weight of the body given by mg. And the distance through which the body is moved is height h. Hence, the work done in lifting the body to a height h is equals to mgh, where m is mass of the body, g is acceleration due to gravity on the surface of the earth. Its value on the surface of the earth is generally taken as 9.8 meter per second square. Approximately its value can be 10 meter per second square. H is the height through which the body is lifted. The height to which the body is lifted from the ground, the vertical height. H is the vertical height through which the body is displaced from the ground. Hence, work done in lifting a body is equals to W, which is equals to mgh. So, keeping in this mind, let us try to solve the few numericals based on this. So, let us start with the first numerical from worksheet 2. A person of mass 50 kg climbs a tower of height 72 meters. The work done is. So, what is given, children? It was given that the person wishes to climb a tower whose height is 72 meters. The height of the tower is given as 72 meters. The mass of the person who is climbing this tower, okay, is given as 50 kg. Mass of the person is 50 kg and he is climbing up the tower. The work done is, what is the formula for work done, children? Work done is equals to weight of the body into this height through which the body is moved. So W equals to weight of the body is, mass here is 50, acceleration due to gravity G is taken as 9.8 and distance or the height the body moves is taken as 72 meters. So simplifying further, we get this value as 72 into 5 is 35280. So what is the correct answer, children? 35280 joules. So the work done by this person to climb the tower of height 72 meters is found to be 3252580 joules, and hence the second option must be true. So now moving to the next question. How much is the mass of a man if he has to do 2500 joules of work in climbing a tree of 5 meters tall? So what is given, children? Already given that the work done in climbing the tree is 2500 joules, whereas the height of the tree is given as 5 meters and you are asked to find the mass of the body. As we know, the formula for work done as W equals to mgh. Hence, the value of mass, as you are asked to find the mass, the value of mass m is equals to W by, bringing the GH this way, W by GH. Hence, the value of m equals to, where is the work done, children? Work done, they have given it as 2500 joules upon the value of G is 10 meter per second square and the value of H, height of the tree, is given as 5. So simplifying further, the 0 and 0 gets cancelled, 5 goes 50 times. Hence, mass of the man is found to be 50 kg. So here the correct option is option 3, that is 50 kg. So now moving to the next question, third one, an object of 100 kg is lifted to a height of 10 meters. Mass is given as 100 kg, height is given as 10 meters vertically. What will be the work done? So same as previous, we have formula for work done is mgh, where the value of mass is given as how much? 100 kg. And acceleration due to gravity G, its value is taken as 9.8. Height through which its object is being lifted is given as 10 meters. So solving these three, we'll be getting it as 9800 joules. So work done in lifting the object to a height 10 meters is found to be 9800 joules. Fourth one, a box of mass 2 kg is pushed along a floor through 2 meters against a force of friction 5 Newton. What is the frictional force here? It is given as 5 Newton. The same box is lifted up through a height of 2 meters. What will be the work done in both cases respectively? So there are two cases given here. Earlier, first case, the box was pushed along the floor. So some work is done. Again, the same box is lifted up to a height, some height 2 meters, and there also some work is done. You are asked to find the work done in each case. First of all, let us try to find the case 1. For the case 1, let us consider this horizontal surface on which a block of mass M is being kept. A box of mass 2 kg. What is the mass of the box given, children? Whose mass is given as 2 kg. So what it was done? So this a box of mass 2 kg is pushed along the floor through 2 meters. So this block was pushed along the floor by a distance of 2 meters. The value of S, distance S is given as 2 meters. Against a force of friction. So whenever a block is supposed to be moving, then the frictional force must be acting in the opposite direction. So if the given that when the frictional force is acting will be 5 Newton, then the applied force must be at least equals to the frictional force to oppose this motion. Okay. So if frictional force is 5 Newton, then applied force must at least be equals to 5 Newtons. So applied force will also be 5 Newton in the opposite direction. Now as the block is being moved to some distance, say something here, this is the new position of the block after covering a distance of 2 meters. Some work is done or not, children? Force is applied, distance is more, so definitely some amount of work is done. So what is the work done here? The amount of work done in pushing the block of mass to a distance of 2 meters is equals to, our general formula is W equals to F dot S. So how much is the force applied? 5 Newton. Applied force is equals to 5 Newton. And what is the distance moved? S is equals to 2 meters. So W is equals to force F is 5 Newton multiplied by distance through which it is moved is 2 meters. Hence 10 joules of work is done in pushing the block along the surface, along the floor. So in moving the block from here, in displacing the block from the initial position to this final position, the amount of work done is taken as 10 joules. So where is the 10 joules? Maybe fourth option or first option might be true. So let us also check the second case. In the second case, what they did is the same box is lifted up through a height of 2 meters. Now, so the same box is what they did is they have now lifted up through some height. So when the block is lifted up to certain height, mass of the block is 2 kg, and given that it was lifted by a height of, how much is the height, children? 2 meters. Height lifted is 2 meters. So in this case also you are asked to find the work done. So work done in lifting a block is equals to weight of the block into height, mgh. Work done in lifting the block is stored in the form of mgh. So what is m? The mass of the block is taken as 2. Acceleration due to gravity g is taken as 9.8. The height through which it was lifted is 2. So now 2 into 9.8 into 2 is equals to, how much is that, children? 39.2 joules. What is that? So work done in lifting the block to a height 2 meters is 39.2, whereas the work done in pushing the block or moving along the floor is taken as 10 joules. Same mass and same distance is moved, but here the acceleration due to gravity affects. Hence, the condition varies. Okay. So now moving to the next question, children. Question number 5. A coolie lifts a box of 15 kg from the ground to a height of 2 meters. So again, a block is being lifted upwards to a height of 2 meters. And mass of the block is now given as 15 kg. The work done by the coolie in lifting the box is. So the same pattern, let us follow the same pattern, children. First of all, let us consider the block whose mass is 15 kg. Whose mass is 15 kg. and this block of mass is being lifted to a height. How much is the height? A coolie lifts a box of 15 kg from the ground to a height of 2 meters. This direction it is being lifted. The work done by the coolie on the block is, work done formula as we know that, weight of the body into height through which it is being lifted. So how much is the mass given? Mass of the block is given as 15 kg. G is acceleration due to gravity, whose value is taken as 9.8 meter per second square, whereas the height h through which the body is lifted is 2 meters. Hence, work done in lifting the block is equals to (294 joules. So, what is the answer, children? 294 joules. And hence, the correct option must be option 2. So, what is the correct option? Option 2, that is, work done in lifting the block is found to be 294 joules. Moving ahead with the next question. Sixth one, a work of 4,900 joules. How much work it was given? 4,900 joules of work is done on a load of mass 50 kg to lift it to a certain height, unknown height. Here work done is given but height is unknown. So what is the height through which the load is to be lifted? So again the same conditions, children. Here a block of mass, how much mass is given? Yes. So, the mass of the object is given as 50 kg. And it was lifted to certain height whose height is unknown. Lifted to certain height. And the amount of work done in this case is given as 4,900 joules of work. So, from the formula W equals to mgh, weight of the body into height, W itself is given as 4,900, mass of the block is given as 50 kg, and acceleration due to gravity, as in they haven't given, you can either take the value as 9.8 or 10. Let me take it as 9.8 only, and height you have to find out. It all matters whether if the given values are multiples of 9.8, you must take it as 9.8, if not 10. So the values will tell you through practice only. You'll get whether to take 9.8 or 10. You'll get it through practice only. So, in order to find the value of h is found to be 4,900 upon 5 times of 9.8. Sorry. So, 50 times of 9.8 and removing the decimal 0 into 9.8, I can make it as 5 times of 98. So, I just multiplied 50 with 0 with the 9.8, then it becomes 5 into 98. So, that is what I have written. So, now simplification gives you 49 2 times and here 49 100 times. That's it. So now 5 2s will be getting it as 5 goes 20 times and 2 goes 10 times. Hence the value of h is found to be how much, children? 10 meters. The value of h is found to be 10 meters. Therefore, the correct option is option 3. Simple formula W equals to mgh or h equals to W by mg. W is given as 4,900, mass is given as 50 kg. Acceleration due to gravity, you have to consider it as 9.8. So, simplified, you'll be getting the height as 10 meters. So moving ahead with the next question, a body of mass 1 kg. What is the mass given? 1 kg is lifted through a height of 1 meter. Then its work done is. So lifting condition, work done formula is mgh, whose mass is given as 1 kg. Acceleration due to gravity, options is the multiple of 9.8. So I am taking it as 9.8 and height is 1 meter. So work done is equals to 9.8 joules. Units of work done is joules. So option 2 must be true, that is 9.8 joules. Moving ahead with the 9th question, children. A man lifts a brick of mass 5 kg from the floor to a shelf 2 meters height. So what is the given data? Mass of the body is given as 5 kg and height through which it is lifted is 2 meters. Okay, and you are asked to find out the work done. Gravity value as of course given as 9.8. So formula for work done is equals to weight of the body through which until which the height to which it is lifted. Mass is 5 kg. Acceleration due to gravity g is 9.8. Height to which it is being lifted is 2. Hence the value of W, work done, is found to be 98 joules. So what is the value of work done, children? Option number 3, that is 98 joules. So moving with the next question, 9th one. A ball of mass 1 kg. What is the mass? 1 kg ball of mass is there. It reaches a maximum height of 5 meters. What is the height through which the ball is raised? 5 meters. So what is the work done by the force of gravity during this motion? So the same old formula, children, work done is equals to mgh. Who is doing this work? The work is done against the gravity. Okay, so work done against the gravity or work done due to gravity. This is what you are asked to find out. So no difference. Only ask the framing of the question is different, but nothing. So this work is done against the force of gravity. So this is what you are asked to find out. So work done against gravity is equals to mass m is given as 1 kg, acceleration due to gravity 9.8 and height through which it is lifted is 5. Hence the value is found to be 8 5s 40, 49.0 joules, or simply W can be written as 49 joules. Therefore the correct option is option 3, that is 49 joules. So now moving ahead with the next question, that is 10th question, and this must be the last one from this exercise. A load of 100 kg. What is the mass? Load of 100 kg means mass is given as 100 kg. Pulled upwards by 5 meters, calculate the work done. So work done formula is mgh. Mass, load of 100 kg means mass is 100 kg. Acceleration due to gravity is 9.8. Height through which it is lifted upwards is 5 meters. So multiplying throughout this, we have 8 5s 40, 9 5s 45, 49, and this will be 0. So what is the correct option, children? Work done in lifting a mass of 100 kg upwards by a distance of 5 meter is found to be 4,900 joules, and hence option 1 must be true. So with this we have concluded or completed with the numerical part from this worksheet 2. Okay, so keep practicing, children, and let us meet in the next video. Until then, take care. Thank you.